For our first example here in section 8.3, trigonometric integrals, it's going to become important that you familiarize yourself with the information in the gray box here entitled Guidelines for Evaluating Integrals Involving Sine and Cosine. And particularly for our problem number 1, as you can see, our sine is raised to the 3rd power, where our cosine is raised to the 4th power, which obviously categorizes that as number 1 here, when your sine is odd and positive, and your cosine, in this case, it would be an even number 4, but particularly it's the sine being odd that takes precedence here. And the key is to save one sine factor and to convert the remaining factors to cosines. And really all that means in this particular problem here is to split apart this sine cubed so that you rewrite it as sine squared of x, and then I'll go ahead and put the cosine to the 4th afterwards, but I have to keep in mind that I owe a sine to the 1st still to the problem, and I'll just put it out here at the end so it won't sort of get in the way of our powered up sine and cosine. Now once that's done, you'll notice that you've got a sine squared that you can easily change to 1 minus cosine squared by using the popular Pythagorean identity. Nothing else will change in the integrand in this step. And the resulting is that integral that I've just written. Now at this stage, you see that sine of x still off here to the right, and you want to leave him here, leave him in that position. But as far as the 1 minus cosine squared and the cosine to the 4th, we can easily do a distributive rule there, and we would get, of course, cosine to the 4th of x minus cosine to the 6th power. Keep in mind that you are adding the two exponents as a result of the multiplication. And then all of this still being multiplied by that sine of x with respect to x. Now the trick is to break this apart into two integrals where each one would contain that sine of x term, because that sine of x term is going to be very important as it will serve as your derivative of u. So in doing that, our first integral would be cosine to the 4th of x times sine of x dx. And then we'll drop down our minus that was here in the middle, and we would now integrate the cosine to the 6th of x times sine of x with respect to x. And now as you can see, we've got something interesting at play here. Both of these integrals that remain have something in common in that the u value will be cosine of x for both of them. So I could write u equal cosine of x, and of course the resulting derivative of u, which would be negative sine of x dx. Don't forget the negative there. When the derivative is taken of a trig word that starts with c, your answer is always negative. And that same substitution will hold true for both of those integrals. So what will happen, and I'll kind of move this over here to the right, is essentially I'm now going to be integrating not the cosine to the 4th, because I let u be cosine. So I'm essentially integrating u to the 4th. And because my derivative is negative sine of x, I'm okay in that I have this nice match for this sine of x and even that dx term, albeit I do owe a negative to that integral, which I can easily put out in front. So in essence, I'm just going to integrate u to the 4th with respect to u and throw a negative sign in front of it. Now, the same thing is going to happen for the second integral, in that this negative sign is going to take a hold of the negative that's already out in front, so I would now be adding the integral u to the 6th with respect to u. And as you can see, you've got two very simple integrals here to take care of that are now written in terms of u. So we'll take those two, and that's our result. And then, of course, like all integrations where you have performed a u substitution, you want to make sure that you complete it with the back substitution. And recall all along that the u was cosine of x. So we replace our u's with the cosine, and we have negative cosine to the 5th of x all over 5, make sure that negative can be seen there, plus cosine to the 7th power of x over 7, and then of course our plus c. And now we have our solution. And of course you could use your TI Inspire graphing calculator and check this.